Okay, let's look at a proof of one of the key impossibility theorems. For this theorem, we're going to assume that our agenda is totally blocked. And what totally blocked means is that for any two propositions in the agenda, there exists a sequence of propositions from the agenda such that P, which equals P1, conditionally entails P2, which conditionally entails P3, ... which conditionally entails Q. So there's a path of conditional entailment from one proposition to any other proposition in the agenda. Now remember that conditional entailment means that there is some subset of the agenda which is consistent with P and consistent with not Q. So what this means is Y union P is consistent and Y union not Q is consistent, such that P together with Y implies Q. So this is a valid inference. Any way of making P together with all of the formulas in Y true must make Q true. So that's totally blocked. Even number negatable means that there's a minimally inconsistent subset. So being a minimally inconsistent subset means that you're inconsistent and every proper subset is consistent. So you're inconsistent, but if you remove just one formula, you become consistent. So there's a minimally inconsistent subset such that you can find some even-sized subset of Y, such that if you flip all of the formulas in Z, you become consistent. So you find some Z, which is of even size, such that if you look at all the Z and put a negation sign in front of them, so you replace Z with the negation of all of the formulas in Z, then that set becomes consistent. So that's even number negatable. What we're going to prove is the theorem that says if our agenda is totally blocked and even number negatable, then every aggregation function satisfying universal domain, collective rationality, independence, and unanimity must be a dictatorship. So that's the theorem we're going to prove. We're going to follow the proof that's laid out by Christian List in this nice review article discussing many topics in judgment aggregation. So the key notion we need is what it means to say that a coalition of voters or a coalition of agents is winning for P. So what that means is that if you give me any profile whatsoever, if that profile is such that everybody in C accepts P and everybody outside of C does not accept P, so what that means is that they accept the negation of P, that follows by completeness of our judgment aggregation sets or our judgment sets. So if take any profile and in that profile everybody in C accepts P, judges P to be true, and everybody outside of C judges P to be false, in that case, then society has to accept P. So let script C sub P be the set of all coalitions that are winning for P. So all collections of agents that are winning for P. Our first claim is that if P conditionally entails Q, then any winning coalition for P must be a winning coalition for Q. So recall that if P conditionally entails Q, that means that there exists some set Y, some subset of the agenda Y, such that Y union P and Y union not Q is consistent, and Y union P logically entails Q. So now we want to show that if, suppose C is a winning coalition for P, then our claim is that C must be a winning coalition for Q. So let's prove that C is a winning coalition for Q. So in order to do that, let's take a look at a particular profile. So let this be the set of all agents and consider this set C, which is the winning coalition for P. Now let's suppose that everybody inside of C accepts Y, together with the formulas P and Q. And everybody outside of C accepts Y together with not P and not Q. Now, the first thing to note is that Y union P and Q is consistent. Now, why is that? Well, this follows, I'll just put it in parentheses here, since Y union P is consistent and Y union P logically entails Q. If that's the case, then Y union P and Q have to also be consistent. Similarly, we have Y union not P and not Q is consistent. Now, why is that? Well, that's very similar reasoning. Note that Y union not Q is consistent, and since Y union P logically entails Q, we have Y union not Q logically entails not P. That's just a fact of propositional logic, so I'll write this down to remind you. Y union not Q is consistent, and Y union not Q logically entails not P. So we have these two sets are consistent. Now, since these two sets are consistent, we can extend them to a maximally consistent set. So let's let A denote this generated agenda, and then F of A is the agenda, the aggregation set that's accepted given this particular profile. So now, I want to somehow prove that Q has to be an element of F of A. So my claim is that Q is an element of F of A. Now, why is that the case? Well, first of all, note that by unanimity, since everybody accepts Y, everybody inside of C and everybody outside of C accepts Y, we have Y must be a subset of F of A. So everybody accepts all of the formulas in Y. Since C is winning for P, we have that P must be in the winning judgment set. So P must be socially accepted because everybody inside of C accepts P, everybody outside of C accepts not P, and C is winning for P. Since C is winning for P. So P is accepted by the judgment set. Now, it follows since Y union P logically entails Q, by collective rationality, this means that Q has to be accepted by society. And why is that? Well, the socially accepted judgment set by collective rationality is going to be complete and deductively closed. So Q is accepted by society under this very particular profile. But by independence, this means that Q is accepted for all profiles A prime, such that A and A prime agree on Q. Meaning that if somebody accepts Q in A, they accept Q in A prime, and if somebody accepts the negation of Q in A, then they accept the negation of Q in A prime. So by independence, we have that Q is accepted under any profile in which everybody in C accepts Q and everybody outside of C accepts not Q. So this proves that C is in fact winning a winning coalition for Q as desired. Next, if the agenda is totally blocked, then in fact we only have one set of winning coalitions. So if something's a winning coalition for P, then it's a winning coalition for Q, and vice versa. So the proof of this is pretty straightforward. Since P is totally the agenda is totally blocked, given P and Q in the agenda, there exist P1 up to Pk such that P equals P1, which conditionally entails P2, which conditionally entails P3, and so on. There's a path of conditional entailment that leads to Q. Well, by the previous claim, we know that if C is winning for P, which is equal to P1, then C must be winning also for P2, because P1 conditionally entails P2. Well, if C is winning for P2, then C must be winning for P3, since P2 conditionally entails P3, and so on, which implies that C must be winning for Q. We also have, there exist P1 prime, P2 prime, and so on, PL prime, such that starting at Q, there's a conditional entailment path that leads back to P. It may not necessarily be the same path or same propositions. All we need is that there is at least one path. So PL prime, which is equal to P. And again, we have if C is winning for Q, then C must be winning for P2 prime, which implies that C must be winning for P. So we have that if C is winning for P, then C must be winning for Q. And if C is winning for Q, then C must be winning for P. That follows directly from the previous claim. So this shows me that given any two propositions, the set of winning coalitions must be the same. So there really is just one set of winning coalitions. So let C, the script C, denote that set of winning coalitions. So C is equal to the set of winning coalitions for some proposition P, and hence, by the claim, this is true for all propositions P. So now let's prove a few things about the set C of winning coalitions. So the first thing we're going to prove is that the set of winning coalitions is closed under supersets. So if C is a winning coalition for some proposition, hence for all propositions, and C prime is a superset of C, then C prime must also be a winning coalition. So the proof makes use of the fact that we're assuming that the agenda is even number negatable. What that means is that there exists some set Y, which is a subset of the agenda, such that Y is minimally inconsistent, and there exists some subset of Y, Z, such that Z is even, the number of elements in Z is even, and if we take Y and throw out all of the propositions in Z, and then we add the negation of all the propositions in Z, then that resulting set is consistent. So for completeness, or let's just say without loss of generality, let's assume that Z is just equal to the set PQ. So given some set C, so let C be an element of script C. So C is a winning coalition for some proposition, and C is a subset of C prime. Our claim is that C prime is, in fact, a winning coalition. So to prove that C prime is a winning coalition, we just have to prove that C prime is a winning coalition for some proposition in the agenda. And what we're going to show is that C prime is winning for not Q. That's the proposition we're going to use to show that C prime is a winning coalition. All right, so in order to do that, let's construct a profile. This N is the set of all agents. We have our set C, which is a winning coalition. And now we have a larger set C prime. And let's say that all of the agents in C except Y minus Q together with not Q. All the agents in C prime minus C, so everybody in between here, they accept Y minus PQ together with not P and not Q. And finally, everybody outside of C prime except all the formulas in y minus P together with not P. So the first thing to note is that each of these sets, y minus q together with not q, y minus pq together with not p and not q, and y minus p together with not p, each of these sets is consistent. And that follows because z is equal to pq, and we know that y minus z together with the negation of all the elements in z is in fact consistent. So we can use this. Each of these consistent sets can be extended to a maximally consistent set to construct a profile A. So we have this profile A, and our claim is that society must accept not Q under this profile A. So why is that the case? Well, first of all, note by unanimity, that implies that since everybody accepts y minus pq, society has to accept y minus pq. So everybody inside of C accepts y minus q, everybody in C prime minus C accepts y minus pq, and everybody outside of C prime accepts y minus p. So everybody, all the agents accept y minus pq. So society accepts that. Since C is winning, we know that it's winning for each proposition. So this implies that C is in fact winning for P. And note that everybody inside of C accepts P, and everybody outside of C accepts not P. So everybody in C prime minus C accepts not P, and everybody outside of C prime accepts not P. So this implies that society must accept P as well. And so now the question is, does society accept Q? So that's our question. Well, suppose it does. If society accepts Q, then what do we have? Well, we have society accepts y minus pq, society accepts p, and society accepts q. This implies that society accepts all of y, because remember, z is equal to pq, so we've just removed pq from y, and then we added it back in. But this implies that f of a is inconsistent, because remember, y was assumed to be minimally inconsistent. That's a contradiction. So it must be the case that y is not an element of f of a. Q is not an element of f of a. So society does not accept Q, which implies society accepts not Q. Since society accepts not Q, that's what we were trying to prove, that society accepts not Q. So then by independence, no matter what the pattern of acceptance is, as long as everybody inside of C prime accepts not Q and everybody outside of C prime accepts Q, then society must accept not Q. So C prime is a winning coalition for negation of Q, which implies that C prime is a winning coalition. So that's the end of the proof of this claim. So let's now show that the set of winning coalition is closed under intersection. So in order to do that, we're going to make use of the fact that our agenda is even number negatable. So what that means in particular, that there is some subset y of the agenda such that y is minimally inconsistent and y contains at least 3 elements, at least 3 propositions. The reason for that is because y being even number negatable means that we can find a subset of even size, which means that since y itself is inconsistent, means the subset must be greater than or equal to size 2. So y itself must contain at least 3 propositions in it. So let's suppose that those 3 propositions are P, Q, and R. So these 3 propositions are in Y. And Y itself is minimally inconsistent. So if we remove any proper subset of Y, it must be consistent. So we want to show suppose that C1 and C2 are winning coalitions. Our claim is that C1 intersection C2 is a winning coalition. So in order to do that, we must show that C1 intersection C2 is winning for some proposition, and the proposition we're going to choose is not R. We're going to show that C1 intersection C2 is winning for not R. That's what we want to show. So in order to do that, let's start with a pattern of acceptance. So we have a set N of agents, and we have our set C1, which is a winning coalition. We have our other set C2, which is also a winning coalition. And let's say that everybody in C1 intersection C2, everybody in there accepts all of the formulas in Y minus R together with not R. Everybody in C1 minus C1 intersection C2 accepts all of the formulas in Y minus Q together with not Q. Everybody in C2 minus C1 intersection C2 accepts all of the formulas in Y minus P together with not P. And finally, everybody outside of C1 union C2 accepts all of the formulas in Y minus PQ together with not P and not Q. The first thing to note, since Y itself is minimally inconsistent, each of these sets, Y minus PQ, union not P and not Q, each of these sets here is consistent. So we can extend each of those consistent sets to maximally consistent set to construct a profile. And our claim is that society under this profile must accept not R. So let's see why that's the case. Well, first of all, note that everybody accepts Y minus PQ. So by unanimity, we have Y minus PQ is accepted by everybody. So by unanimity, society has to accept all the formulas in Y except for P and Q. Secondly, note that C1 is a winning coalition. Since C1 is a winning coalition, and everybody in C1 accepts P, and everybody outside of C1 accepts not P, we have that society must accept P. Similarly, since C2 is a winning coalition, and everybody inside of C2 accepts Q, and everybody outside of C2 accepts not Q, we have Q must be accepted by society. So now the question is, does society accept R? Well, again, by collective rationality, I claim that R is not an element of f of A. Because if R was an element of f of A, so if society accepted R, then society would accept all of Y, but we know that Y is inconsistent, and that would mean society is inconsistent. Since society is not inconsistent, R cannot be accepted, which implies not R is accepted. Now, again, we use independence to argue that if we have any profile where the pattern of acceptance for not Q and Q is exactly as it is in A, then, for not R and R is exactly as it is under A, then society has to accept not R. So C1 intersection C2 is winning for not R, which implies C1 intersection C2 must be winning. So let's summarize. We've shown that if the agenda is totally blocked, then there exists exactly one set of winning coalitions. So there's a set, if a coalition is winning for some proposition P, then it's winning for all propositions. We've then been able to show that this set of winning coalitions has certain algebraic properties, namely it's closed under superset and it's closed under intersection. We also have that the entire group of agents, the whole society, must be a winning coalition. This follows from unanimity. Because if everybody accepts some proposition P, then society has to accept that proposition P. That's just to say that the whole society, all the agents, is a winning coalition. We have this fifth property, which says that for any coalition, for any subset of agents, either C is a winning coalition or the complement of C is a winning coalition. So why is that the case? Well, suppose that C is not a winning coalition. What does that mean? Well, that means there is some proposition P such that there exists some profile A1 up to AN such that for all I in C, everybody in C accepts P, and for all I not in C, they accept not P. But society does not accept P. Well, by collective rationality, since society does not accept P, that implies society accepts not P. But what does this mean? Well, this implies actually by independence not the complement of C is winning for the negation of P. Because here we have an example where everybody outside of C accepts the negation of P. Society accepts the negation of P. So any profile that has the exact same pattern of acceptance for not P and P must be such that society accepts not P as well. So the complement of C is winning for not P, and as we've seen a number of times, that implies that not C is in fact a winning coalition. Finally, we're going to show that there must be a single agent such that the singleton I is a winning coalition. If that's the case, then there must exist a dictator. This I is in fact a dictator. That's what it means to be a singleton that's a winning coalition. In order to see that, suppose that n is equal to 1, 2, 3. So we number all of the voters or all of our agents, 1, 2, 3 up to n. Now note that consider the set 1, singleton 1, together with the complement of 1. So this is 2, 3, 4, up to n. One of these two sets must be a winning coalition. This follows from property 5. So if 1 is a winning coalition, then we're done. Agent 1 is our dictator. But if 1 is not a winning coalition, that implies that 2, 3, 4, up to n, the remaining set, the complement of 1, is a winning coalition. So now consider singleton 2 together with the complement, which is 1, 3, 4, up to n. Again, either the set singleton 2 or its complement is a winning coalition. If it's 2, then we're done. 2 is our dictator. But if singleton 2 is not a winning coalition, this means that the set 1, 3, 4 up to n is a winning coalition. And we keep going to the stage where we ask, is singleton n minus 1 a winning coalition? So we consider singleton n minus 1 and the set 1, 2, 3 up to n minus 2, n. And again, if n minus 1 is a winning coalition, singleton n minus 1 is a winning coalition, then we're done. If not, if n minus 1 is not a winning coalition, then the set 1, 2, 3, n minus 2, n is a winning coalition. And now note that we've shown, if we're in a situation where we haven't found our dictator yet, the claim is that singleton n must be a winning coalition. And why is that? Well, take the intersection of all of the sets 2, 3, 4 up to n, 1, 3, 4 up to n,
1, 3, 5 up to n, 1, 2, 3, n minus 2 up to n. Since all of those sets I know are winning coalition, their intersection is a winning coalition, but their intersection must be n, because n is the only agent that appears in all of these winning coalitions. So singleton n in this case must be the winning coalition. So no matter what, there must exist a dictator. There must exist an agent such that that agent alone is a winning coalition.